Okay, for the Rydberg part, the Rydberg equation part, you are going to use, let's pick a different color. You're going to use all of this. Okay, notice in the Rydberg equation, the lower energy level is going to go first. Then you're going to put the higher one second, so that you don't get a negative number. Okay. Anything that falls to n equals 1 is UV, also known as lemon series. Falls to visible, which is n equals 2, and Balmer series falls to n equals 3, which is infrared, and passion series. This is the emission spectrum. Okay. Also note that as you get closer to the nucleus, you have higher energy. So n equals 1 is going to have a higher energy than n equals 2. This is n equals 1, the first shell, and n equals 2. Okay, so we'll talk more about that as we go. Let's go on to the question part. Okay, and A can be solved by looking at your memorizations. Let's go on to these. Remember, falls to n equals 1, n equals 2, n equals 3. And if we go back to our memorizations, 12, they're all right here. N equals 1 is UV and the lemon series. N equals 2 is visible and Balmer. N equals 3 is passion. Okay. So you'll be able to do all of those. C, E, with that information. Now let's put to use our Rydberg equation. So which of the following transition emits the highest energy for the photon? So you're going to use the equation with the 1 over n squared minus 1 over n squared. So remember, the lower value goes first and the higher value goes first. The higher value goes second and the second n. So this one's asking which of the following transition emits the highest energy of the photon. You technically don't have to do all this math because, as I said before, when you get closer to the nucleus, which are low numbers, you have high energy. But high energy means low wavelength. So you would pick D because 2 and 1 are going to be the closest. 8 and 10 are very far away and they have low energy. But they do have a high wavelength. 2 to 1, that's going to be a very high energy and low wavelength. Okay. E can be answered using the falls to n equals 1, n equals 2, n equals 3.